Hi there. Last class we talked a lot about ozone, and today I just want to add in one more idea. So we'll start with a review of what we've already learned. Ozone is found in two different places on our planet. When we find ozone in the stratosphere, it is good ozone because it protects us from ultraviolet radiation because UV rays are mutagens. They can change the DNA in the cells of living things. When ozone is found in the layer of the atmosphere that is closer to us, the troposphere, it is bad ozone because it is an ingredient for smog. What ozone specifically does in the stratosphere is it blocks out all UVC radiation, which is the most damaging, most UVB radiation. It does allow UVA radiation to pass through, but that radiation is not very damaging to the cells of living things. We get many health benefits because of stratospheric ozone. Specifically, we have lower rates of sunburn, we have lower rates of skin cancer, and we have lower rates of eye damage, specifically with something called cataracts, which is damage to the cells in our eyes over repeated exposure to UV radiation with no protection. We already talked about how ozone is formed in the stratosphere, but let's just review. It is a natural cycle where UV radiation, UVC specifically, breaks the bond holding two oxygen atoms together in oxygen gas, also called diatomic oxygen, freeing up two oxygen atoms, and oxygen atoms can then go and chemically bond to diatomic oxygen to form O3, which is ozone. This ozone is not only created by this natural process, but it is also broken down naturally so that it's a complete and natural cycle. So the UV radiation can also break apart bonds in an ozone molecule and turn it into O2 plus free-floating oxygen, which can then bond with another O2 molecule, and we constantly create and break down ozone in the stratosphere. But just like UV radiation can break chemical bonds in ozone, so can certain chemicals. And the worst chemical that destroys stratospheric ozone is something called a CFC, which stands for chlorofluorocarbons. Now, we used to use them in the United States to make aerosols, which means anything in a spray can like paint or hairspray or deodorant. And they also act as cooling agents, so we used to use them in refrigerators and air conditioners, and we even can use them to make styrofoam. But they destroy the ozone, and this is how they do that. A chlorofluorocarbon molecule can have the bond broken by UV radiation, and it can release a chlorine atom, represented by this big yellow circle. That chlorine atom can bond with an ozone molecule and pull away one of the oxygen atoms and then release an O2 oxygen gas molecule. But then it is free to go and bond with other ozone molecules. So one chlorine atom can destroy thousands of ozone molecules in the stratosphere. Now, this is what the chemical formula looks like. It's not as scary as it seems. This is the chemical formula for chlorofluorocarbon. Notice it has 3 chlorine atoms. When one of the bonds is broken by UV radiation, it frees up one of those chlorine atoms, and this is the culprit that can then go and bond with ozone and pull away an oxygen atom, thus destroying ozone. And again, one chlorine atom can potentially destroy thousands of ozone molecules. The good news for the United States is that in 1987, we signed the Montreal Protocol, and so did many other nations, and that said we will stop using CFC chemicals in our products, and we will reduce the use of other ozone-depleting chemicals. Unfortunately, many developing countries still use CFCs, and also, even though we stopped using CFCs in 1987, they remain in the atmosphere a really long time. they can stay there for decades. So even though the thinning ozone layer, which is really what's happening with what people call the hole in the ozone, even though the ozone layer is slowly repairing itself, it will take a long time to fully repair because CFCs remain in the atmosphere for a very long time and some countries are still using them. This video summarizes all of the big ideas.
Hey, want some sunscreen? This stuff is really strong. SPF 4000 or something.
Nah, I don't need it. I've heard the ozone in the atmosphere protects me from the sun's harmful rays.
Really? Is that true? Is the ozone a good thing? I've always heard that it was bad. And what is ozone anyways?
Great questions. Ozone is important, and it can be good or bad depending on where it is. Ozone is a gas made up of 3 oxygen atoms bonded together that occurs in the Earth's atmosphere. In the troposphere, where we live and where airplanes fly, small amounts of ozone are produced naturally by plants and lightning. A larger amount is put there by human activities like factory and car emissions, which contributes to air pollution.
Ozone in the troposphere isn't a good thing.
But in the stratosphere, the layer above the troposphere, ozone is a good thing. It protects us from much of the sun's harmful ultraviolet radiation.
Ozone helps to block most UV radiation coming from the sun. That's because instead of the radiation making it all the way to the Earth's surface, the radiation is absorbed by ozone and oxygen molecules. This radiation provides the energy needed for a series of reactions to occur. These reactions destroy and create ozone all the time. In the stratosphere, UV radiation breaks up oxygen molecules into free oxygen atoms. These free atoms bond with other oxygen molecules to form ozone. UV radiation is also absorbed by ozone molecules. This breaks ozone apart into oxygen molecules and single, very reactive oxygen atoms. This system is in balance, or equilibrium, because both the destruction and creation of ozone happen at the same rate.
So ozone always stays the same? What about this ozone hole I've heard of?
Right, the hole. The stratosphere might seem far away from us, but it isn't immune to human impacts. In the 1970s, scientists who had been monitoring the amount of ozone in the stratosphere over Antarctica since the 1950s noticed that it was the lowest they'd ever seen. In the 1920s, humans started using gases called chlorofluorocarbons, or CFCs, in refrigerators, air conditioners, and later in aerosol sprays. Over time, these CFC gases made their way up through the atmosphere into the stratosphere. In the stratosphere, UV radiation strikes CFC molecules, which causes them to release a free chlorine atom.
A chlorine atom can react with ozone, and it converts the ozone into O2 and a CLO molecule. And then a CLO molecule can react with an oxygen atom, and that forms O2, but the chlorine atoms reform again. And then the CLO plus O creates the chlorine atom again and another O2 molecule. So the net is you've taken ozone and you've converted it into 2 molecules of O2. So ozone goes to a regular oxygen molecule, right? But the chlorine atom is still there. And that's how it can act like a little Pac-Man and go on and eat up 100,000 ozone molecules. So that's a catalytic process.
Oh, that's what the ozone hole is.
It's not so much a hole as a thinning in the ozone layer, but that's still a problem. But there is good news. After noticing the low levels of ozone, in 1987, an international treaty called the Montreal Protocol was put into place to ban CFCs. Eventually, all 197 countries in the United Nations joined the ban. And it's been successful. Since 1993, CFC levels in the atmosphere have decreased significantly.
That's great news for the ozone layer and for us. The U.S. Environmental Protection Agency says that the Montreal Protocol can help prevent millions of cases of deadly skin cancer from occurring in the future. But you should still wear sunscreen because even a healthy ozone layer doesn't block all of the sun's harmful UV radiation.
Oh, okay.